Hello people, welcome to the blockchain talk. So today I'm going to try to code one Dapp. So Dapp stands for decentralized applications, and I'm going to try to do it with Truffle. Truffle is a framework for Solidity, for making contracts in Ethereum. So first I'm gonna let you know what I need for this. That's basically I will use MetaMask. You will need to install MetaMask. I'm not gonna go through the installation. It's simple basically. Then I will assume that you are already a developer. You did some stuff with JavaScript. You have some basic knowledge. So we will today build something that usually you would do like with normal centralized servers, with APIs, with all of these things, and you build just applications. So the idea is to build pet shop and build application for adoption of pets, dogs, or cats, whatever. So basically that's you can find also on their website tutorial about that. It's exactly here. So here is how to build basically Dapp with the Truffle. So let's start. First what we will need a terminal, and what we're gonna do is so now we're gonna enter to pet shop, and here we want to initialize the Truffle. So first what you need to do is you need to install the Truffle. Installation of the Truffle is going like this: npm install Truffle globally, and then you basically have it in your console, so you can do different things with that. Here are some of the commands. On the Truffle you can find out more what you can do with that. So what we want to do now is we want to we can initialize the empty project, or since we're gonna do a front end and the back end of this application, basically we will use one of the boxes. So the boxes that are here, you have different things. So you have some already done, like for example for this pet shop. So we will use this box to create this small application. Wow. So we want to do unbox. So now the Truffle will unbox pet shop. So we have now our box here, and what we want to do is, like, we got some stuff inside. We want to open this and see in the editor how it looks. Project, and our project is pet shop. Now we here have a contract, we have migrations, we have node modules, source, and tests, and some packages and stuff like that. So we will go through each thing why it's important. So basically, first thing what we're gonna do is we will go and build a contract. There is currently no contract for what we want to do. So we're gonna add a new file, and we'll call it adoptions, because we want to adopt adoption sol. So you need to always to add sol at the end. That's a Solidity language. And when you're here, you can do Solidity. So basically importing Solidity. I will just copy that part from somewhere. So it goes like this. So we will do this, and now we basically imported in our contract Solidity. Next thing what we want to do is to create a contract. No. So we have a contract adoption. At the moment doesn't do nothing. So what we want to do is to add some functionalities inside. The first functionality that we want to add inside is basically a function for adopting the pets. But before we add that, we want to set up some variable. So we will add address variable, and we will say it's a 16-digit long address can be. We'll make it accessible to public, so we don't need to make a getter. And we will write variable name adapters, so it means all the addresses of adapters will be saved into this variable. The next thing, we want to make a function for adapting. So we will give it a name, adopt. So when we want to adopt, we will put, we will give a kind of ID to the function, so the function can associate certain ID of the pet with a certain address, so which person actually adopted the pet. So parameter that goes in is first we write a type, because it's just the type strong language. So type is int, and then the name of the parameter is pet ID. Next, what we want to do is we want to make it public and return integer again, so the number. Actually want to return a pet ID. So the next thing is that we require that pet ID is between 0, so bigger than 0, and the less than 15. So require condition is pet ID should be bigger or equal to 0, and pet ID should be smaller. Sorry for keyboard, it's not computer where I usually code. 15. This is because like we are checking to make sure that pet ID is in the range of our adopters array. So arrays in Solidity are indexed from 0, so ID value will need to be between 0 and 15. We use require to state to ensure that ID is within this range. So because we, as we said, like we said, there is a 16-digit addresses. So the next thing is we want to say, okay, if the pet ID is correct, we go to adapters. So we take this variable, we add the pet ID. So this is how we will find exactly the adapter by the pet ID. And then we will basically message sender. So the one who will execute this function in our smart contract, adopt, so the address or the person that will execute this function in this contract will be message sender. So we will have here his address, So the pet is under ID 10. The message sender will be saved that he adopted the pet under the ID 10. So we return the pet. Always put a semicolon, otherwise it will not work and will not compile. You will get error out. So this is our first function. The second thing what we want to do is like we want to get all adapters. So we want to make a function get adapters. So this is a getter, doesn't have any parameter. And we'll return type address 16. So when we have that, we can basically return our adapters. So this function will do exactly what you see here. When it's called, it will basically just return all adapters that are inside. We can adapt the pet, so we can store the certain pet under certain address of the sender, and we can return all the adapters. That's for now that. So let's go save it, and this is our smart contract. And how to deploy it on a network? It's basically really easy. We need to go here. First thing what you need to do here is to install Test Rpc. That's our test network for Ethereum network. So you don't work on a global network where all the transactions are real Ethereum is. You work on a test network where actually you can develop different kind of application. So to install Test Rpc, you will need just to go and grab it from their GitHub. And install it like this, and after that you can just do Test Rpc, and this will just run your local Ethereum network. So it automatically created a few accounts. So basically the same accounts that you created on real network, like to put some Bitcoin or Ethereums on it, you get it here, and each of them already have some Ethereum associated by default. We will see later how much they have. It's at around 100 Ethereum inside in each of them. So and this is also your kind of mnemonic random words that you usually also create when you creating things on like when you starting your wallet and creating address and all these things. So what you want to do is you want to go to the folder where we created, and you want to compile, because this is a, as we see here, this is contract that it's written in Solidity, but virtual machine that runs Ethereum network accept compiled version of this code. So basically we need to compile it, and we do it like this: Truffle compile. What he will do, he will just go and find the contracts. So in this moment he found adoption and migration contract. Migration was from before here, and he is used basically to migrate contracts to add new functions, and I don't know, to add the new contracts inside. Yeah. So now when the compilation is done, we have a build folder, and inside there is a contract. So that's our builded contract. This is how it looks. It has a binary contract inside, has some functions and stuff like that. What this contract does, timestamp and everything else. So Now we have a contract, but it's still not on Ethereum network. So we want to push this contract on Ethereum network. So Truffle migrate. So in this moment, Truffle migrate will not work because we didn't write any migration. So we need to go and write migrations. But we need to make our own migration to deploy our adoption contract to the network. So how to do it? We will also create one new file and call it second deploy contract JS. So this is our kind of migration script for deployment of contracts. And it's, as you see, it's a JavaScript. So everybody who is familiar with JavaScript can actually write this code. Also, this one was not that much strange, and like Solidity was similar to JavaScript. So let's do adoption migration contract here, a migration script here. So first what we need to do is we need to grab our adoption contract. So we do it like this. We basically just assign a variable, adoption, and artifact. So artifacts require, and we add our adoption dot solve. So basically, this, when we run the Truffle, he will know by this script where to find the adoption. So he will just look into the contracts and he will find the adoption solve, and he will basically require it. And when we have that, now what we do is we need to export it. Module.export function. So the deployer will be passed when this function is called, and then we basically need to deploy this contract. So what we see here, it's very simple migration script for deploying, and what it does, it's just a script that requires our smart contract and basically deploy it. So now when we have that, we can just go here and write Truffle migrate, and this will run the script. So it runs both scripts, initial migration and deployer contract. We have some error here, migration on the second script. Something was wrong. Stupid. So you just need to save your file when you edit it. So always remember, save. I'm used just to different editor who saves automatically, like IntelliJ. So this one I use it first time today, so I have a little bit of troubles. So let's see if it now works. Yes, now it works. So it deployed contract JS. So now when we have both contracts on Ethereum network, we know that we also spend some gas for deployment. And if we take a look in before mentioned meta task, we need to unlock it to be able to interact with our Ethereum network. So second thing what we need to do is, like, now we have a built kind of a backend, like we have Ethereum contract, we have Ethereum network, test one, and I would like to just to show you something before we go to front end. So we need to grab this mnemonic and then just paste it here so we can actually unlock Okay, now we unlocked our MetaMask and we can exactly see here. Usually it's 100 Ethereum that you get with each account. So we use this account and we have less than 100. So what it means that we spent some gas on Ethereum to deploy our contracts to Ethereum network, and they're at the moment there. So let's build an in-user interface to interact with this network. We can do that. Also here are already some stuff so we don't need to code all of these things to not be too long. So the main thing is in app.js. They predefined some stuff for us. Basically, I will also not code everything from the scratch. I will also copy some stuff from them and explain how they work. So what you need to do is, so we have this big, I mean, you can use here React, anything, but for this purpose of this demo app, they use just pure JavaScript and so we have here defined the main object app, and inside there are some functions, some methods and stuff like that. So basically what we want to do is like we want to, when the Windows browser is ready and everything is loaded, then we initiate the application and basically we calling this init function that basically will get our pet JSON. So here are defined some pets, their ID, picture, location, and all these things. So it will get this one, and then it will just create kind of a template for them and boxes where they will be like in the front end. And after that it will initiate Web3. So here is interesting thing that it comes. So Web3 will be basically Web3 is JavaScript library that allow us to interact from the front end with the Ethereum network. So the same what we write in Ethereum with Solidity, we can now do in the front end, so that we can interact with this function that we wrote in Solidity for Ethereum network. So to do that, we will basically first I will just copy and explain what it means. So in the moment when we turn the browser, our test network in this moment will inject, so this guy will inject Web3 inside. So if there is no no Web3, so if we are not like on a main network, we will go and we will create basically, this is our local host where our Ethereum network is running. So this guy, if you take a look up, I'm not sure if it's written here, but yeah, it's running on local host 8545. So this is what we want to do. We want to take a Web3 and basically attach this, so tell to Web3, hey, you should connect, instantiate new Web3 object, and tell him, okay, you should connect to this blockchain network. So after that we can initialize contract, and to do that we will need to basically get the contract. But we were getting the contract that was as we showed before in JSON format, our compiled version of it. So we get the compiled version of that, and we have, so all the contract compiled, we have it here now, and we can pass it into our Truffle contracts, so he will understand what each function and method inside means. And we set the provider that we instantiate before, so we have it up on beginning, it's a null, so we instantiate it, and then now basically we pass it in to set the provider in the contracts. When we did that, we call mark adapt. That's in a case we already did it. We already used this application, then we refresh that. On initialization we check which pets are adopted, and we can then show some graphics that this pet is already adopted or similar. So here in mark adopted we need to make some logic for that to be able to do that. So what we want to do there is basically, so what is going on here, okay, so this event we already know, we see what's happened. It's just pure JavaScript. It's just binding events. When you click on some handle, that it will actually call this handle adapt function to do something. We will get later to that, but it's just our handles are binded with this function. So we come back to our mark adapt function where we actually want to interact with our blockchain network. So app contracts, adoption deployed. So this is the same thing what we did before. Then just assign this instance of deployed contract and return. So we just call get adapters. We call this function, but basically we can see it here like get adapters. We're calling this function and we're retrieving all the adapters that are stored inside. So when we get them, we will return them and we will have all adapters. So this function here will not execute any ether. We don't store anything, we're just retrieving. We will then go through each of them and check if some of them is not 0. So what this means? It means that we define it here that there are 16-digit numbers addresses, and that they will basically all of them will be created with zeros, and if any of them has different address, so if this is something different than just empty addresses, then we can say, okay, this panel will be success and disabled, so you cannot adopt the pet that is already adopted. In the case of error, we just catch the error in console log. So that's basically what this function mark adopted is doing. So basically just going there, getting all the addresses and checking for each address for each pet. If there is any pet that has different address than this, if yes, then just mark it as success, mark it as adopted pet. The next thing what we want to do is basically what we seen here is like we seen handle adapt. So we bind this event to handle adapt function that it's here, and we need to, like, each time when somebody press this handle to adopt pet, we need to call the Ethereum network and say, okay, this pet is adopted by this address. So what we're gonna do is here is basically this code here. So as I said, I will not write all of them because it will be too long video, so I will just explain what this is doing. So when we click a handle, of course, we do classical JavaScript and default event, and then we basically taking ID of that pet from like their data ID that's stored. So here we see that we store data ID on beginning, and we can retrieve it here, and we just write variable adoption instance and basically going. So what we're doing here, it's just Web3 that can interact with Ethereum network, and it will just tell him like, okay, give me all the accounts that you have. This is these accounts on our private network, and we will for now just grab the first one, and then we will say, okay, the app contract adoption deploy on this instance of the contract, call the function adopt and pass pet ID, and also we need to pass account. This is needed because in this moment we will spend some ether, some gas. We are going to send transaction instead of a call, and transaction require from address and have a associated cost. The cost is paid in ether and it's called gas. The gas cost is a fee for performing computation and storing the data in a smart contract. We send transaction by executing adopt and the function with both pet ID and the object containing account addresses which we stored earlier in account. So what will happen now, from this account will be taken gas, some ether. And when this is done, it will basically call our function mark adopt, and it will execute this one. As we seen before, we did our front end. This is our application. Let's save it. And what we can do here is, so we have deployed contract, we have running network. So what we need to do is, of course, you need to install one more thing. To have some kind of a server, so we will use a light server. Okay, this is how you install your light server, and this is what you need to do. Basically here it's already this configuration, and it tells like, okay, look into the source and look into the build contract. So look here and look into the build contracts. This is the two things that we need to serve in order to, why build contracts? Because we will need adoptions. So that's why. And we will need also source, where it stored our pets and our index and all these things. So now we have a package JSON and we have a script that is there, and it's this light server. So when we go here, when we do npm run dev, we will run light server, and he will have instructions to basically look into this folder, run this index HTML, take pets JSON, and also take adoptions from the contracts. Okay, that's our website, that's our application, and we can take a look here. I'll put it on this side so it's easier for us. What is going on here? Console, network, so MetaMask injected Web3. So we already have MetaMask from before, as we said, running. We spent some ether, and MetaMask actually injected Web3 object. This is an object that we will use to interact with the Ethereum network that is running on our console. To not go deep inside what each of these things is doing, you have their Web3 GitHub. So you can basically read documentation here and all the possibilities, all the possible usage and everything else. So let's come back here, and now what we want to do is we want to adopt Melissa. In the moment when we click this, MetaMask will come and say, okay, you want to do something, you want to execute some function on a smart contract, and this will cost you some ether. In this moment it will cost 20 gas price and gas limit. So I say, okay, let's do it. And what we did now, we can see that here we did this transaction, and we saved to the block that we adapted Melissa. Unfortunately, we didn't get back that it's adapted. Ah, it works. Okay, so now it works. So each time when we refresh, it basically knows that it's a success. So let's adopt another one. Yeah, we adopted even this one. So we can see that address that was there, it's actually this address. So our MetaMask is working. Okay, that was all, guys. So we just made a small demo app, a pet shop on a blockchain. So thank you guys, and see you in the next video. Leave some comments, make some questions.